Okay, very good evening, everyone, to the NPTEL 7th live interactive session on the course Engineering Metrology. The course instructor for this course are Professor J. Ram Kumar and Professor Amandeep C. Oberoi. I am an additional TA Shubham Jaiswal. I am a research scholar in the Department of Material Science and Engineering at IIT Kanpur. Okay, so in this live interactive session, we will be going to solve some sample problems related to your weekly content, which will in turn help you to solve your weekly assignment. Okay, so as this is the live interactive session, I hope for the interaction. Okay, and let's proceed to our sample problem. But before solving the sample problem, we will quickly recapitulate what we have seen in the last week content. So in the last week content, we started with the surface metrology. In surface metrology, we have seen what is meant by surface. Then we have some terminologies related to the surface metrology. In that, we have seen the definition of roughness according to ASTME. Then we have seen the waviness. Then what mean by layer, flaws. Then we have seen the surface texture, and also we have seen the error of form. Okay, so in error of form, we have seen the bow, necking, and lobbing. Similarly, in surface texture, we have seen that the surface texture includes roughness, waviness, lay and flaw. Okay. So similarly, in lay, similarly after that we have seen the analysis of surface traces. Okay. So after that we have seen the analysis of surface traces. Okay. So in this one we have seen the like how the analysis of the surface is done. Like there are different methods. So we have seen the 10-point height average method, also known as peak to valley height. Prashanta, am I audible?
Yes, sir. Yes.
So in the 10 point, what we do, we take a 10 points, like 5 peaks and 5 valleys, and we take its average. Okay. So RZ is nothing but divided by 5 into 1000 and vertical magnification, and this gives values in terms of micrometer. Okay, and after that we have seen the second method, that is the RMS value, also known as the full form is root mean square. Okay, so formula for RMS is H square plus S square plus HN square divided by N. So after this we have seen the center line average method. Okay, so generally center line average method is preferred over the RMS method. Center line average value. Okay. So RA is nothing but summation of all the peak and values. Okay, summation of all the peak and value in the considered length. So irrespective of their sign, we add them. So after this, we have seen the method for measuring the surface finish. So in this one, we have seen two methods. One is the comparison method, like visual inspection or by touch. We talk about the surface finish of the surface, and the second method is the direct measurement method. In direct measurement method, we have seen the stylus system of measurement. So all these things we have seen in the surface metrology. Then we went to the temperature measurement. In temperature measurement, we have seen the scale used to measure the temperature. So in this one, we have seen the two types. First one is the relative scale, that includes Fahrenheit scale and Celsius scale. And in the absolute scale, we have seen the Rankine scale and Kelvin scale. So after that, we have seen the what are the relation between the different temperature scale. So if we talk about the relation between the Fahrenheit scale and Celsius scale, so Fahrenheit scale can be related as 0.8 to the Celsius scale. Okay, so this is degree centigrade, and centigrade scale can be related to as using this second equation. Okay. So the Rankine scale can be correlated with the Fahrenheit scale using the equation given in 3. Similarly, the Kelvin scale can be related as Celsius scale plus 273. So this will give us the relation between the scale. Okay. So after that, we have seen the method of measurement of temperature. Okay. So in method of measurement of temperature, we have seen the two methods. The first one is the contact type. So in contact type, what are the different instruments that we have seen are the thermocouple. So in thermocouple also we have seen the thermopiles. Then we have seen the liquid in glass, that is LIG thermometer. Then we have seen the resistance temperature detector, that is RTD. After that, we have seen some pressure thermometer, thermistor, and bimetallic. So, pressure thermometer. Then we have seen the thermistor and bimetallic. So, in these 6 instruments we have seen in the contact type, and in non-contact type we have seen the radiation pyrometer, then optical pyrometer, and fiber optic thermometer. So these are the things we have seen in the temperature measurement. Okay, after that we went to the pressure measurement. So after that we have seen the Prashant, am I audible, na?
Yes, sir, audible.
Okay. So we will soon solve some problems. So, but I'm
yes, sir.
repeating these things. Okay. So after that we have seen the pressure measurement. Okay. In pressure measurement, what we have seen, what is meant by pressure, and after that we have seen some scales in pressure measurement. So in this, what we have seen are gauge pressure. I mean, that is gauge scale. What is gauge pressure? Then total pressure. Okay, so gauge pressure is nothing but the pressure above the atmosphere. Above the atmosphere. Then total pressure is the summation of atmospheric pressure plus gauge pressure. Then we have seen the differential pressure. That is the difference in pressure between 2 points. So also we have seen what is meant by vacuum, which is the pressure below the atmospheric pressure is known as the vacuum. So in vacuum, the gauge pressure is negative, whereas the pressure above the atmospheric pressure is the gauge pressure, and that is the positive gauge pressure. But in case of vacuum, the gauge pressure is negative, and also in case of vacuum, the absolute pressure is always positive. So next we have seen the absolute pressure. So in that we have seen the total vacuum or zero vacuum. After this, we have seen the different pressure measuring instrument, such as the manometer.
Sir, which one among these all the measurement? Which one is the best method for measuring pressure?
Pressure, it's depend on the type of application actually.
Okay.
Okay, so
which method? Correct or error? Less error. Which one is the less error or which one is the correct method?
Okay, so most of the methods are accurate one. Okay, but if we consider the electric pressure transducer and elastic transducer, that are the most accurate method. Okay, but if we consider in case of manometer, we have the simple manometer and inclined manometer. So among them, the inclined manometer will be having the higher accuracy and sensitivity because of the inclination. Like this is the manometer, and here we are getting the inclination at some angle. Okay, so the scale will be the larger one, and so we will get the more markings in the same area. So so that's why we will get a higher accuracy in case of the inclined manometer. So depending on the application, we use the most accurate one. Okay, so we have seen the manometer, then we have seen the ring balance. Okay, depending on the application. Okay, when we need to measure the pressure inside the bicycle tire or motorcycle tire, we can use the Burden tube.
Yes, sir.
Yeah, because accuracy does not matter that much. Okay, but in process control, where we need to measure the pressure, that time we need a most accurate one. Like we use the electric pressure transducer. There are also different types. Okay, that I will also explain in this one.
Okay.
So in a ring, after ring balance, we have seen the inverted bell manometer, and after that we have seen the elastic transducer, and we have seen the electric pressure transducer, and that too are different types like resistance. Then second one is the potentiometric, then inductive type, capacitive type, and piezoelectric type. And then at the end we have seen the dead weight pressure gauge. Then after the measuring of the pressure above the atmospheric pressure, then we move to the measurement of vacuum pressure. So in this one we have seen the different gauges, that is a Metrology gauge. Then we have seen the Pirani gauge. So Pirani gauge works on the principle of thermal conductivity, and Metrology gauge works on the Boyle's law. After that we have seen the ionization gauge. And then at the end we have seen the Knudsen gauge. So the ionization gauge is used for medium and high vacuum measurement. And Knudsen gauge is used for low pressure or low time. So these are the things that we have covered in the last week. Now moving to our problem solving. So we will solve some problems related to your weak content. So the first question is, the one may choose a casting or rolling or forging operation if the surface is rough, if the rough surface is not acceptable. Is it true or false? Yeah, Prashanta, what do you think?
I think true.
Any other? Any other options, anyone?
I think, sir, no one in there.
No. There, Gitanjali is there. Yeah. So, what do you think, the answer of this question? One may choose a casting, rolling or forging operations if rough surface is not acceptable. Okay. So, Prashanta, the answer is false. Okay, why? If the surface is rough, okay, means rough surface is not acceptable. What that means? We need a good surface finish. Okay. But if we consider the casting, rolling or forging, like suppose if I have a 30 plus minus 0.1 sample diameter or the product dimension, so only this much accuracy, that is 0.1 accuracy I am getting, or the 0.1 finish I am getting. But if we need the higher finish, then we need to go for some other operations like grinding and polishing. So if we need a good surface finish, we need to go with the machining with some grinding and polishing operation. So here they have asked, one may choose casting, rolling or forging operation if rough surface is not acceptable. So if the rough surface is acceptable, then definitely we can go with the casting, rolling or forging. But in this case, this is not the case. So the answer will be the false. Moving to second question. So it is the blank space. These are the non-contact type sensor for measurement of temperature. optical pyrometer, thermocouple, thermistor, all of these.
Optical pyrometer.
Optical pyrometer. Yeah, you are right, Mr. Prashanta. As among these options, the optical pyrometer is only the non-contact type sensor for measurement of the temperature. Like in thermocouple, we will have one hot junction. Suppose this is hot junction. This is maintained at cold junction. So to measure the temperature, we need to make the contact. Yes, Mr. Shankarna, Mr. Swamiji, would you like to say something?
Gas is ready for SLC.
So in thermocouple, we need a physical contact to measure the temperature. Similarly, in thermistor, it is nothing but a semiconductor that works on the principle of resistance, decrease in or increase in the resistance with the changing temperature. So in that case, also we need a physical contact. Okay. So among these, only the thermocouple. Among this, the optical pyrometer is only the non-contact type sensor for measurement of temperature. So, moving to our third question. Platinum has small temperature coefficient of resistance. So, is it true or false? Mr. Chandu, Mr. Prashanta?
Sir, false, I think. I think false.
Yeah. So, Mr. Chandu, what do you think?
Sir, true.
Okay, so we have two answers. So, the correct answer is false. So, the platinum has the higher coefficient of resistance. So, moving to our next question. So, next question is like that. The difference between the atmospheric pressure and the absolute pressure is known as differential pressure, vacuum pressure, total pressure, or none of these. Anyone? Mr. Prashanta, Mr. Chandu, Mr. Broderick? So the difference between the atmospheric, yeah, Mr. Prashant.
Differential pressure.
Yeah, you are right, Mr. Chandu. The difference between the atmospheric pressure and the absolute pressure is known as the differential pressure. Okay, because we are measuring the difference between the 2 points. That is the one in the atmospheric and one is the absolute pressure. So this is the differential pressure. So, moving to our next question. In case of vacuum, the gauge pressure is positive, negative, zero, none of these.
Negative.
Any other options? Mr. Chandu, Mr. Roderick? Okay, let's see. So I will draw the scales. So let's say this is our atmospheric pressure. This is our local reference pressure, and at the top we have gauge pressure. Okay, so this one is gauge pressure, and below the vacuum, sorry for the below the atmospheric pressure we have the vacuum. So if the pressure above the local reference pressure or atmospheric pressure, if the pressure is above the atmospheric pressure, then that is the positive gauge pressure. But if it is below the atmospheric pressure, that is vacuum, so it will be the negative gauge pressure. So the correct answer will be the, in case of vacuum, the the gauge pressure is negative. So moving to our next question. The inverted Bell manometer is capable of measuring absolute pressure, positive and negative pressure, or differential pressure, or all of these. Anyone? Mr. Prashanta, Mr. Chandu, Mr. Umesh, Mr. Rodrigo. Anyone? Hello.
Differential pressure.
Mr. Chandu, Mr. Umesh, Mr. Rodrigo.
So differential pressure.
So let's see. So let me draw the sketch of the inverted Bell manometer. Okay. So this is our inverted Bell manometer. So if we need to measure the pressure, so we can measure all this type of pressure like absolute pressure, positive and negative pressure, and differential pressure. Okay. So only the thing is that depending on the reference pressure or the pressure on the other side, like this side, we can measure the all these types of pressure. Like we can measure the absolute pressure, we can measure the positive pressure, and we can measure the differential pressure. Or it means we can measure the all of these. Like we can at the one end we can take the atmospheric pressure. We can maintain the atmospheric pressure on the one side, and from the other side we can measure the absolute pressure. Similarly, we can take a we can maintain a negative pressure on a other side, and we can also measure the negative pressure. So depending on the pressure on the reference side, we can measure all these types of pressure, that is absolute pressure, positive and negative pressure, and differential pressure. So moving to our next question. In a metallic capsule, in case of elastic transducer, the relation between the deflection and the pressure remains linear, non-linear, inverted, none of these. It's very simple. You can just by observing like how the relation will needs. Depending on that, you can easily answer. Yeah, Mr. Prashanta, Chandu, Mr. Umesh, Mr. Roderick. Anyone? Am I audible, na? Hello?
Yes, sir.
Yes, sir.
Yeah, please respond, guys. This session is for you only.
I think linear.
Okay. So, yeah, linear. Your right, Prashanta.
Say inverted. Say inverted.
No. Linear, because in most of the cases, when in metallic capsule, the relation between the deflection and pressure is always linear. Okay. If it is not gone beyond its threshold limit. So, moving to our next question. Convert 32 degrees centigrade to Fahrenheit scale. Please solve this one and tell me the answer. It's very simple. I have already given you the formula in previous slides, like in the beginning itself.
Sorry, 89.6 degree Fahrenheit.
Okay. Any other option?
Just a minute. $89.6 degrees Fahrenheit.
Okay. So let's solve this question. So the relation between the centigrade scale and Fahrenheit scale is given as F is equal to 1 degree Fahrenheit is equal to degree centigrade plus 32. Here the degree centigrade is given as 32. So degree Fahrenheit 1.8 into 32 plus 32. So this is 57.6 plus 32. It comes out to be 89.6 degree Fahrenheit. So the correct answer will be the 89.6 degrees Fahrenheit. So this is just a conversion, okay, like how we can convert temperature from centigrade to Fahrenheit scale, okay. So as many of you have joined late, I will write down all the formulas. That is the relation between the different scale. So first is the Fahrenheit. Sorry, it's plus. The second one is degree Celsius, Fahrenheit minus 32 divided by 1.8. Similarly, the Kelvin scale can be the Celsius scale can be converted into Kelvin scale by adding 273 in the centigrade scale. Similarly, the Rankine scale, that is the rank plus 460. So these are the four conversion formula to convert one scale from to another. Like if the temperature is given in the Fahrenheit, you can convert it into the you can convert it into the degree Celsius. Then you can convert it into the Kelvin. So you can use this formula accordingly in what scale you need. In case of the scientific research and mathematical studies, the scale used is Kelvin scale or Rankine. In general, we use the degree Celsius scale. That is the most famous and easy to read scale. Okay. So moving to our next question. A pyrometer can be used to measure the temperature of surface remotely. Is it true or false? Yeah.
True, sir.
Yeah, true. Mr. Umesh, is it true?
True, sir.
What do you think, Mr. Prashanta, Mr. Roderick, Mr. Swami?
True, sir.
Me,
True,
I
sir.
think also it's true.
True, sir.
Yeah, the pyrometer can be used to measure the temperature of the surface remotely. It is the non-contact type. It is the non-contact type temperature measuring instrument. So we have different types of the non-contact type pyrometer. That is, if we write some, that is radiation pyrometer. Then optical pyrometer and fiber optic pyrometer. So this is the answer is true. So moving to our next question. The reason for the surface irregularities are feed marks of cutting tool, chatter marks on the workpiece, rupture of workpiece material, or all of these?
All of this, sir.
And why is it so? Like,
Yes, all of this.
can you elaborate little a bit, like how these different things will produce the surface irregularities on the surface? Okay, tell me the effect of feed marks of the cutting tool. So, yeah, you're all right. The question, the correct answer is all of these. Okay, all these things like feed marks, if the feed is not proper and the angle is not set, then also we can get the surface irregularities, and the chatter during the machining will also affect the surface of the component. Okay, it will produce some marks, scratches, and some like that. And if the rupture of the workpiece material, like if it's a rupture or some deformation is taking place, that is also produce some surface irregularities. So the correct answer will be the all of these. So moving to the next question. Which of the following is not a major factor that brings surface irregularities? So you can correlate previous question and answer this question. So the options are feed mass cutting tools, scatter mass on workpiece due to vibration caused during the manufacturing operation, fineness on the surface due to rupture of workpiece material during the metal cutting operation, surface variation caused by deformation of workpiece under the action of cutting forces. So what do you think? Which will be the correct one?
I think that is thickness on surface due to rupture of workpiece material.
Okay. Any other option?
Surface variation.
Okay. So the correct answer is fineness on the surface. Okay. Due to the rupture of the workpiece material during the metal cutting operation. So here we are talking about the surface irregularities. How much the irregularities are found on the surface. So the feed mass, that also brings the subsurface irregularities. Similarly, the chatter that also we have seen that is due to the vibration during the machining also causes the surface irregularities. Similarly, the surface variation, like if we are deforming the workpiece under the action of the cutting forces. Okay, so if the cutting forces are involved, definitely there will be the some surface variation will cause. The only option that is the fineness. Like if the surface is more fine, means it is the surface is moving toward the regularities. Okay, like it is not irregular, means the surface is fine or the smooth. So the only option here is the fineness on the surface due to rupture of workpiece material during the metal cutting operation. So moving to our next question. Fluid flow measurement is measured the speed of flow by calculating the progress of surface flows by using. This is one-liner question. In last week contents also sir has covered.
Gravity method.
So the correct answer is ultrasonic method. So in the upcoming session, we will discuss like all these four methods, and in that I will clarify like why is ultrasonic method, why not the gravity method. Okay. So moving to our third question. A thermocoil comprises a number of thermocouples connected in parallel, wherein the hot junctions are arranged side by side or in a star formation. Is it true or false?
True, sir.
Okay. Any other option? Mr. Roderick, Mr. Chandu? Okay. Mr. Umesh, what do you think? A thermopile comprises a number of thermocouples connected in parallel, wherein the hot junctions are arranged side by side or in a star formation. Okay, let's see. The thermopiles are derived from the thermocouple. Means if you use more thermocouples and that too in the series. Okay, if the thermocouple are used in the series, then it is known as the thermopile, and the connect that the hot junctions are either arranged side by side or in star formation. like we can arrange thermocouples like this in the series. Or also we can use a thermocouple in star formation. So series star. So here the like this is the side by side, okay? Sorry, side by side. So here they are saying the thermopile comprises a number of thermocouples connected in a parallel. Okay, they are saying it is connected in a parallel, but in thermopile the thermocouples are connected in a series. Okay, they are connected in a series. So the correct answer will be the false. Moving to next question. Which of the following is not a type of error of forms? Bow, cracks, lobbing, snaking. Anyone? Mr. Chandu, Mr. Roderick, Mr. Umesh?
Cracks. For me, cracks.
Yeah, Mr. Roderick, you are right. The correct is the cracks. Okay. We have seen as in the lecture the error of forms are first one is bow, lobbing and snaking. So moving to our next question. Peak to valley height is also known as root mean square value, 10-point height average value, center line average value, none of these.
So 10-point height average value.
Okay, yeah, Mr. Prabhakaranji. Yeah. Any other option? Mr. Chandu, Mr. Roderick? Okay. Let's see. Okay. So here we are considering the peak to height value, okay, and that is also another name of the 10-point average height average value. So the correct answer is 10-point height average. What we do, we take the 5 peaks and 5 valleys, and we take its average, and that will give us the average height of the surface. So that is the 10-point height average value, and it is denoted by RZ. And the formula is like the higher, like the sum of the height of peaks minus the sum of the height of valleys. That is
Valleys. H2, H4, H6, etc.
divided by 5.
Yeah.
And this is vertical magnification, and generally we get this value in the range of micrometer. Okay. So moving to our next question. The medium pressure are more difficult to measure than low pressures. Is it true or false?
False.
Any other options? Mr. Ram, Mr. Chandu, Mr. Roderick?
False.
Yeah, you all are right. The correct answer is false, because low pressure is very difficult to measure as compared to the our gauge pressure and medium pressure. So high vacuum will be there, and we need an instrument to work like that can measure the vacuum more accurately, or the low pressures. Like not much deflections will cause in the low pressures if we use the deflection type of instrument. So Prabhakaran ji, we will discuss your question in the last time you asked about the autopolymeter. So we will discuss that one in the last. Okay.
Yes, Ji, thank you, thank you.
Yes.
Sorry, I could not attend last week because I was engaged in my wife's, she is under bedridden, under hospitalized. So I could not attend this 6 to 7 last week, Ji. Yeah.
Okay.
Thanks for your remembrance and calling me. And
Yeah.
before closing, I need one more doubt to be clarified in this assignment.
I'll wait for your choice.
Okay. So moving to the next question. The average height from the mean line of all ordinates of the surface, regardless of sign, is called. RMS value, RZ value, RA value.
So maybe RA value or A?
I am not very sure, sir.
Okay. Let's see. We will wait for some other answers. Mr. Chandu, Mr. Umesh, Mr. Ram, Mr. Swami, Mr. Roderick. What do you think?
Sir, RZ value.
Okay, let's see. Okay. So suppose this is my surface and having some surface roughness, and this is my mean line. Okay. So this is mean line. So here they have given the mean line. Okay. If we take the height above this one or this one, and we doesn't consider it sign in case of the only RA value, that is the center line average value. Okay, it is RA is center line average value. So in only RA value we doesn't consider the its sign. So the correct answer will be the array value. Okay, as we are taking the average height, like this is the mean line, so this is the average height, like it will give the, like we are considering the average height of the peak and values, and we are adding that one, we are considering some portion of length, and we are adding, like suppose this is A1, A2, A3, A4, so the RA will be A1 plus A2 plus A3 plus A4 divided by L. So in case of only the RA value or center line average value, we consider a mean line and we take the average height regardless of its sign. So moving to our next question. Which of the following is the best analogy for the stress of stylus instrument? A topographical map, a rolling ball, a phonograph, a pinball machine. Like which is in the best analogy? Like which is more similar to that of the stress of stylus instrument? Anyone?
Maybe topographical map.
Okay. Any other options?
Maybe rolling ball.
Sir, a phonograph.
So we have three different options. So let's see. If we consider a topographical map, so it gives the information about the topography. Like if we consider the topographical map of Earth, it gives the information on the various topographies. Okay. But remember, they have asked about the analogy, best analogy, that's trace of a stylus instrument. So in stylus instrument, what will happen? We will be having one pointer. Okay, and we will be scribing it or moving it over the surface. Okay. Surface. And that if there are any deviations or surface irregularities, that will be seen on the scale. Okay, or we can also record it on the paper or some other films. So in the topographical map cannot do these things. Like we can't trace. Okay, we can't use the stylus and trace it. Okay. Similarly, if we consider a pinball machine that in the childhood we used to play. If you go to any gaming center, you can easily see the pinball machine. It will be like this one. Okay, you will have some display here. Okay, and here one ball will be there, and you need to using sticks. You will try to bring this ball to this hole. Okay, so definitely this can be the answer. So also pinball option we can. If we consider a phonograph, the another name of phonograph is gramophone. So we will have one horn like this one horn we will have, and here one square table. Okay, and here we will have one turntable. Okay, and this turntable, and we will put a disc on this one, and we keep a stylus. Like in olden days, the gramophone, like we will keep a disc on this one, then we will bring the stylus down, and it will trace the turntable, and accordingly the music will play. So here stylus. So this is in the analogy. Yes, Mr. Prabhakaranji.
Yeah. No, I just understood the gramophone exactly. In my days, I have seen exactly the stylus just locates in the circle. I mean, that traces a circle, and we choose the songs like that. Yes.
Yeah. It produces the sound. So that it is the best analogy for the trace of stylus instrument. So
Agree. Now I clear.
The phonograph. Yeah. So moving to our next question. Which of the following statement is true with reference to thermocouple? Thermocouple is an electrical device consisting of two similar electrical contacts forming electrical junctions at same temperature. It is the electrical device consisting of two dissimilar electrical contacts forming electrical junctions at the same temperature, and it is the two dissimilar metal at two different temperatures, or the two similar contacts at different temperatures. So which of the following is true with reference to thermocouple? Please read it carefully and answer. It's very easy question. Anyone? Mr. Chandu, Mr. Ram, Mr. Ujwal, Mr. Roderick, Mr. Umesh.
C option. Option is C.
Let's see. Okay.
I think it's the last proposition.
Let's see. So if we are talking about the thermocouple, so in thermocouple, we use two metals, okay? Two different metals. Okay, so this is metal 1 and this is, let's say, iron and scale here, and this is metal 2.
That's
We maintain both the ends at different temperature. One is the hot temperature and this one is cold temperature. And because of these two dissimilar metals maintained at the hot and cold temperature, and EMF is induced, and that will be proportional to our temperature. So in thermocouple, we need two different metals maintained at two different temperatures. So the only satisfying, this is the main criteria for the thermocouple, and among these four, only the third one, that is the thermocouple, is an electrical device consisting of two dissimilar electrical contacts forming electrical junctions at different temperatures. So only this one is the correct one. So moving to our last question. So is used to measure the very low pressures: ionization gauge, Bridgman's gauge, Knudsen gauge, Metrology gauge.
Ionization gauge.
Ionization gauge. Any other option?
Sir, McLeod gauge.
The correct answer is Knudsen gauge. Okay, we can use Metrology gauge for the low pressure, but if it is very low, we go with the Knudsen gauge. Similarly, we have that one ionization gauge we can use for medium and high vacuum, but for very low pressure, we prefer the Knudsen gauge. So that's it for today, everyone. So if you have doubt in this, any question that we have solved today, you are free to ask. Otherwise, you can leave this session. Prabhakaran, you please be here. We will discuss. Okay.
Hello, Shubham ji.
Yeah, Prabhakaran.
There is one doubt. See, in the liquid in glass thermometers, the main parts which are given are clear. It has been stated in the sketches in PPT also, like scale, bulb, reference point, working liquid, everything. But regarding that inside tube, it's doubt whether it is, no, as far as I am concerned, I think it is a capillary tube. Yeah. But is it capillary tube or boron tube? Normally, boron tube will be coming in for pressure gauges and other thing. Yeah. Am I right, Jay?
Sir,